In this video, we are going to talk about arithmetic sequences. So we talked about several sequences, and we know that this is just a list of numbers. We can try to come up with formulas for them, but we can see that it can be a little bit difficult to find some of the formulas. And in this class, we're going to talk about two different types of sequences. The first type of sequences is what we're going to call arithmetic. So that is the first type of sequence. The other type is what we're going to call geometric. So these are the two types of sequences that we're going to talk about in this class. So let me give you an example of what an arithmetic sequence looks like. And I've done this already. An arithmetic sequence is going to look something like this: 2, 4, 6, 8, 10, 12, and so on and so forth. So what you see, a common number is being added to each of the terms. So that's what an arithmetic sequence is. The difference between each consecutive term is constant. Whereas for a geometric one, an example of this will be 2, 4, 8, 16, 32, so on and so forth. Whereas here, something is being multiplied to the next term or divided by the next term. So arithmetic deals with things that are being added and subtracted, whereas geometric deals with multiplication or division. Okay, so the first type of ones that we're going to do is arithmetic sequences. So let me give you the definition of what an arithmetic sequence is. So an arithmetic sequence is just simply a sequence where the difference between consecutive terms is constant. So that's what an arithmetic sequence is. So the difference between consecutive terms is constant. Okay? So this difference that we have here, this difference, D, we're going to call it D. This is what we're going to call the common difference. And the way that we figure out this common difference, we just take one of the terms and subtract it by the previous term. That will give us the common difference. So one way that you can think about is just A2 minus A1. The second term minus the first term. That will give us the common difference. Okay? So let me give you some examples. Okay, so first, find the common difference. So here is going to be part A, it's going to be 2, 4, 6, and 8 continues. So I think we've seen problems that look like this already. So one way to figure out the common difference, it seems a little bit obvious, but the difference will be, let's just take the second term and subtract it by the first term. Our second term in this case is 4. I'm going to subtract it by our first term, which is 2. So the common difference is going to be 2, which basically means that for every single term, I'm going to be adding 2. And you can always just take a look at it and see that I can add 2 and I'm going to get the next term. So that's what that is. Now can you try to figure out what this one is? 10, 3, negative 4, negative 11, negative 18. So what do you think this one is? Well, let's take the first term and subtract it from the second term. So the second term is going to be 3 minus the first term, which is going to be 10. It's going to give us negative 7. So that means I'm adding negative 7 to each of the terms. And what you can do that. Subtract 7 to each of them, and you'll see that this is actually the common difference. Okay? Now, when we talk about these types of arithmetic sequences, one thing that we want to figure out is, if I know that a sequence is arithmetic, can I think about a formula that I can just plug in? So for example, let's say I had these numbers, set of numbers 2, 4, 6, 8, and I wanted to know what is the, I don't know, 102nd term. Okay. Well, one thing that I don't want to do is continuously add 2 and 2 and 2 and 2 102 times. So a formula would be nice to just plug in 102 and get the values. So here is going to be a formula for arithmetic sequences. For arithmetic sequences. So first I'm going to start off with the first one. So I know that I'm going to start off with A1. That's the first term. Now in order for me to get the second term, I'm going to take A1 and I'm going to add the common difference, right? So I'm going to take like 2 and I'm going to add this 2 and I'm going to get 4. That's how I get the second term. How do I get the third term? Well, I'm going to take the second term and add D to it. But I already know what A2 is. A2 is just equal to A1 plus D. So I'm going to substitute that in there. So A2 is going to be A1 plus D. And then I just happen to have an extra D right here. So I'm going to have A1 plus 2D. Because that's what D plus D is. What is going to be A4? Well, A4 is just going to be A3 plus the common difference. But I already know what A3 is. A3 was this A1 plus 2D. It's going to be A1 plus 2D. Then I have an extra D right there. That's going to give me A1 plus 3D. You could probably already see the pattern. A1 plus D, A1 plus 2D, A1 plus 3D. Can you try to guess what A9 is going to be? Well, this is going to be A1 plus 8D. So as you can tell, this number, whatever this number is always going to be one number below. So as I continue this on to many different terms, I can say that AN is going to be equal to A1 plus n minus 1 times D. This is the formula. Okay, so this is formula for arithmetic sequences. Okay, so that is the formula. So this formula is a formula that we're going to use to try to figure out different terms. Okay, so let's do a problem using this formula. So what we want to figure out is find the 27th term of a sequence where the first term is 7 and the common difference is 9. So we want to find the 27th term of a sequence where the first term is 7, so I start off with 7, and the common difference, so I'm continuously adding 9. So I'm going to add 9 27 times and see what I get. Well, instead of adding 9 27 times to 7, I'm going to just use this formula that we just found out. This AN is equal to A1 plus n minus 1 times D. Okay? Now I know what A1 is. A1 is the first term, which in this case is 7, so I know what that is. What is n in this case? N is just the term that I want. In this case, this is 27. So I want the 27th term. That's what n equals to. D is just going to be my common difference, which is just 9. So all I got to do is just plug in this information into the formula. So AN, n remember is 27, so A27 is going to be equal to A1, which is 7, plus n, which is 27 minus 1, times D, which is equal to 9. So this is going to give me 7 plus 26 times 9. So this is going to give me 241. So this tells me that the 27th term is going to be equal to 241. Okay, so let's try another problem. Find the 18th term of a sequence where the first term is 13 and common difference is -7. So why don't you try that out? So here, let's just go ahead and try it. So we know that the formula for this is going to be an is equal to a1 plus n minus 1 times d. a1, which is the first term, is going to be 13. N in this case is going to be the 18th term, so that's just 18. D in this case is going to be -7. So I'm subtracting 7 to the 13 18 times. So let's plug everything in. So A18 is going to be equal to A1, which is 13, plus 18 minus 1 times D, which is -7. This is going to give me 13 plus 17 times -7. So I'm going to plug this into my calculator, and what I'm going to end up getting is -106. That is going to be my solution. Okay, and now let's do one more problem. Find the 19th term of a sequence where the 5th term is 1 and common difference is -4. Okay? Then find a formula for the general term. Okay? So here we want to find the 19th term of a sequence where the 5th term is 1 and the common difference is -4. And then we're going to find a formula. So let's first write down the formula for arithmetic sequences. That's just an equals a1 plus n minus 1 times d. Okay, so here, notice we don't know what a1 is. So that's unknown to us. We don't know what the first term is. But I do know what the 5th term is. The 5th term, a5, is 1. Okay, the common difference here is -4. So before we even start with A19, I need to figure out what A19 is. But before I know what A19 is, let's figure out what A1 is. So let's use this information that they give us first to try to figure out what A1 is, and then we can figure out what A19 is. So let's first figure out what this is. So A5, I know A5 is going to be equal to A1 plus n in this case is going to be 5 minus 1 times d. D in this case is -4. So let's use this information to figure out what A1 is. A5 in this case is just equal to 1. A1 plus 4 times -4. So I'm going to have 1 is equal to A1 minus 16. I'm going to add the 16 over, and I'm going to get that the first term is going to be equal to 17. Now that I know what A1 is, okay, I can just go ahead and plug it back in here. So I know that AN equals A1, which in this case is 17. So now I just figured out what it was, 17 plus n minus 1 times d. Well, let's plug everything in because now I want a 19. I want to figure out what a 19 is. So n in this case is going to be 19. So I'm going to have a 19 equals 17 plus 19 minus 1 times t, which gives me negative 4. So all I'm going to do is plug everything in here. So I'm going to have 17 plus 19 minus 1 gives me 18. Multiply this by negative 4. This is going to give me negative 55. Okay, and that is going to be my final answer. Now, I got the 19th term. Now, I'm not done with the problem because what do they want to also know? Find a formula for the general term. Okay, so let's figure out this formula. So the formula initially is an equals a1 plus n minus 1 times t. I know what a1 is. a1 is going to give me 17 plus. Now, since I want a general formula, I'm going to keep n by itself. D in this case is a common difference, which in this case is negative 4. All right, and now let's just figure out a formula. An equals 17 plus, let's distribute this out. This is going to give me a negative 4n plus a 4. All I'm left with is this negative 4n. Then this 17 plus a 4 is going to give me positive 21. This is going to be my general formula. So this means that if I want to figure out like the 100th term, all I got to do is plug in the 100 here and it'll give me what the 100th term is.